Hi, welcome to this brief tutorial on generalizing to other possible spin systems. We've been discussed the spin half and spin 1 systems so far. The ideas studied for these two cases can be generalized to other possible spin systems. To make it, new labels must be introduced. I'll introduce the label S to denote the spin of the system. For example, we can have spin half, spin 1, spin 3 half, so on and so forth. You might be noticed the number of beams coming out the Stern-Gerlach analyzer is n equals 2s plus 1. Let's check this out. Remember, for a spin half system, which means S equal half, we had two beams coming out of the Stern-Gerlach analyzer. And for the case of spin 1, we had three beams coming out the Stern-Gerlach analyzer. And if you put these numbers, half and 1, into this equation here, you get this number shown here. Well, you might also be noticed that the eigenvalues in each of these cases range from minus s h bar to plus s h bar in unit steps of h bar. So remember, for the case of spin half, the eigenvalues were minus h bar over 2 and plus h bar over 2. And for the case of spin 1, the eigenvalues were minus h bar, 0, plus h bar, which is in accordance with what I said here. The eigenvalues range from minus h bar to plus h bar. I'll label these possible values of the spin component by the letter m. So all of these values here will be from now on represented by the letter m. So okay, we can therefore think in an eigenequation such as, for the z component, we have sz act upon this ket sm. Now I'm using the new labels, equals m h bar sm. And remember about that operator s squared. We can also have the generalization for that operator, and the eigenvalue equation will be something like this. S squared act upon the ket sm equals s plus 1 h bar squared ket sm, where s is the spin angular momentum quantum number, or the spin quantum number for short, and m is the magnetic quantum number, or spin component quantum number. Now it's time to establishing connections between two words. I mean the old notation with this new one using the labels sm. Previously we had, for the spin half system, ket plus, which now is equivalent to ket half half. The first number here represents our spin quantum number, and the second represents the magnetic quantum number, m. And for spin down, it represents now half and the minus half. Of course, we can do the same for, this is for spin half, and we can do the same for spin 1. Basically, the previous cat 1 will be now 1 1, and the cat 0 will be 1 0, and the cat minus 1 will be 1 minus 1. So I presented this equation for the z component. I'll check this out only for spin half to illustrate that in fact this equation represents a generalization for spin half. So for spin half we have s equals half and m equals plus h bar over 2 and minus h bar over 2. If we plug these values back into our eigenvalue equation, we retrieve the known eigenvalue equations for spin half, which is as z half half equals plus h bar over 2 half half, and the other one is half minus h bar over 2 half minus half, where our cats here in this new notation represents this is our old cat plus, and this is our old cat minus and cat minus. This is all for this tutorial. Thanks for watching. I'll see you later.